Okay, Andy, I'm trying to test this camera. So, let me tell you what I'm doing here. I'm setting the valve clearance between the bucket, right? So you got these buckets. So here is the one that would go in the third intake, which is 1, 2, 3. So like this goes here, right? So here's your tip of your valve. Under this keeper is a valve spring, and then the bucket goes on here, right? Then the cam goes in. Let me throw this back. So the intake's done. Here's the tip of the valve. So here's your shims, right? Of course. So you torque down the cam, and you check the clearance. The spec for this, all of them, intake and exhaust, is 1/10 of a millimeter. So you put them in and you measure it. So for example, this one, and here's the chart. I don't know if you can see it. When I do this one, there is no shim in here. And the clearance in here, let's say, is 0.8 of a millimeter. So I would need to raise that bucket up 0.7 of a millimeter, so that then the clearance decreases to 1/10 of a millimeter. No problem. So here's your shims, right? So you're like, oh, okay. If this gap is reading 0.8 of a millimeter, and it needs to be 1/10 of a millimeter, I need a shim that's 0.7. Problem is, they don't make shims that thin. The thinnest they make is 1.85 millimeters. Because anything less, the shim goes in here like this. Anything less would probably just break. So, why is this why is this situation that I have? It's probably because doing the valve jobs on this, slowly the valves have set from cutting new valves in deeper, so that now the valves are in deeper, right? So it's getting closer and closer without a shim. So what do I do? So what I did, again, the buckets are in here. There are no shims, none. So that's the max distance I can get. So as an example, when I measure these, here's my exhaust 1. I read 0.81 millimeters, right? And of course, you know how to do this. I did it with these, right? Measured it and stuff. So what we're going to do, now that I've measured all this, I'm saying, how much shorter could I make this tip of this valve so I could put a 2.1 shim in there? Because I'd like to put something reasonably thick in there. So instead of what you would typically do is you would recut the valve seat, which would basically move the valve away and create a bigger gap. And instead of doing that, what we're going to try to do is, I just did all the measurements. I'm going to print this worksheet, take it to the machine shop. I could probably do this, but I want them to do it because they'll have a mill. They could put these tips in they're going to take the valve, and I'm going to give them the spec. So here's the spec. I want him, for example, on the first intake valve, I want him to remove 1.29 millimeters. Now that's obviously going to be tough to be 1.29, but get close to that. So he's going to take out the valves, probably put them in a mill, perfectly square in his mill. Then he'll, because he's really accurate, he can lower that mill 1.29 millimeters and just send that mill over the end of that valve. Right? And so there isn't a whole ton of meat, but there's over a millimeter there on each one of these. So it's the same over here. So when I get this back, this little extra piece of meat here should be lower. Now the trick's going to be, if you take off too much, where these keepers connect, you can weaken that. So the machine shop guy might say, hey dude, I can't do this. I'm looking at these valves, and I can't. These valves, by the way, are brand new. He's like, if I take off too much meat, odds are, you know, at higher RPM and stuff, like the tip of this valve will break off, these keepers will cut loose, and it'll hand grenade the whole thing. So what I committed to them was I'd do the measurements today, tell them what I think it needs to be to make it work. Then they're going to see if they can do it. Now, if they can't do it, what we're going to have to do is put in new valve seats, right? We're going to have to, oh, come on. There it goes. We'll have to go over here, and we'll have to do new valve seats. Let me get this in here. Hold on. There. So even though, like, so here's the problem. Here's the exhaust valve. See, obviously these are open because there's a cam in there, right? And you can see the slap in there, right? Because it doesn't have a shim. So worst case, what we'd have to do is cut new valve seats, which would raise these valves 1.5 millimeters. We'd put new valve seats, and then they would cut them, and it would basically move these valves away, and then I could solve it that way. So that's what I'm doing today. That's what I'm working on, and hopefully I can get it figured out, and the guys at the machine shop will say, no, we've done this before. Yeah, we've seen this, you know, happen, and it's not a big deal and whatever. But I do worry that if we take too much off of that, we're going to have a problem. And I wonder where, somewhere, you can see all my bullshit. Like, here's the valve cover. Somewhere in here are the old valves that are bent. But I could look at it actually and see what those valves look like. What did I do with those? What did I do with those other valves? Because I got a couple of them. Are they in here? It's a bunch of more pieces and parts I need as I keep putting this thing together. Anyway, somewhere I'll have to find it. Somewhere I've got the valves. Ah, here we go. So here is an exhaust valve. Perfectly good. Where's this one? No, this one's bent. Okay. Huh. Well, shit, man. Look at that. Look how much meat there is. So the keepers actually grip it right there. Not way up here. So he could take a lot off, actually. This might work really well. So I could actually take one of these out because I got the thing to take and I could check it, but it looks like the keepers are down low. Okay. Ah. All right. This will be interesting. This will be very interesting. Okay. So I just wanted to make this video, and so here's the rest of the motor. Right. So you can see I got all new pistons. It's got a really good hash mark in it. I did hone it a little bit and clean it, but it's really good. So these are brand new pistons, brand new piston pins. And what I did was I weigh every piston and every piston pin on a $500 scale that I have within thousandths of a gram, or is it, no, 1/10 of a gram, 100th of a gram. And then I take a little bit of material off so that I match the pins and so that every one of the piston pins plus the rings plus the piston are practically identical in weight. So once I get this head done and solve my clearance problem I got here, then I'll just keep going. I'll just keep going, you know, get the head on, get it to it. Then it's already timed from your dad. So I don't have to do any timing. I just got to make sure everything's good. So that's why I got my timing wheel. So I know top dead center. Get it on. Once everything's good and my clearance is good, then I'll keep going together. I'll put the clutch in. I may wait to put the clutch in because it's just more weight because I got to pick this up myself. And I'll go to the other side because see how this bracket's welded on, but this one's removable. And then I'll get a motor in, which will probably kill me. Then I'll be able to keep going and get it back together and get it running. So anyway, I thought I'd make a quick video. I'll edit this down, but I thought that way you could see what I'm doing. And so when we're shooting the shit, we can talk about it. See ya.